This video covers topic 14.5, analyzing quadratic functions in the calculator. For these notes, you will need a graphing calculator similar to the one shown on the left, or something that does the same thing as a graphing calculator. You'll also need these notes, so I will flip back and forth through these. So on these notes, we are told up at the top to use a calculator tips page. There's a calculator tips sheet that everyone should have received. So if you were not here and you're taking these notes, it looks like this and can be found on the website. So a couple quick things. If your graph looks funny, so we're going to be looking at some graphs on the calculator. But if your graph looks funny, maybe it's like super far away, the lines are really bolded, you're not seeing what you want, you need to press Zoom 6 for standard. Sometimes you have to press enter, sometimes Zoom 6 will get it. So if you do Zoom 6, this will take you back to your normal 10 by 10. In order to graph, we're going to go to y equals, which we've used before, and so we're going to put stuff in and then click graph. And then we have information about the vertices and x-intercepts and the value that I will go through as we do them. The only thing you need to do on this page is to find the x-intercepts. Other words for x-intercepts are zeros, roots, or solutions. So you need to write this in on your graphing calculator page, because this page is going to be your go-to for all of your calculator things. And so if you see the words zeros and you don't write this down, then you're not going to know what to do. So we're on this page in the notes packet 14.5, and they ask us to graph x squared plus 2x minus 3 in the calculator and answer the following. So I'm going to go to y equals. So if you've cleared your calculator, 2nd plus 7, 1, 2. This is what it looks like. So y equals is in the top left. We've used this before when we factored and we went second table. So we're going to type in x squared, and remember you can also use this little caret button, plus 2x minus 3. So I'm typing in this equation exactly like I see it in my calculator. So as the sheet tells me, put it in y equals and click graph. So this is my graph. So over here, on problem 1, I can draw a rough sketch. Looks something like this, and we'll come back and label some of these pieces as we find them. But this is, again, just a rough sketch. So to find the vertex, we're going to follow these instructions. To find the vertex, we click second trace. So trace is the second one in from graph. We click second trace. The vertex, and I'm sorry I forgot to talk about it, the vertex here is a minimum. You will need to know that before you go to your second trace menu. So this one is a minimum. So I'm trying to make sure you can see this. So because it's in a minimum, we're going to click 3. If it was a max, we would click 4. So second trace, 3 for minimum. And again, if you are like me, you forget to look, you can just go back to graph and see which one it is. So click 3 and enter. Now this asks me for the left bound. I am trying to find, remember my vertex is this low point right here. So that's what I'm trying to find. So I go about where it is, and then it asks me to go to the left. So I'm going to use my left arrows and click to the left of the vertex, and then come down and click enter. Now if you notice, it asked me for the right bound. So I'm going to use the right arrows, scroll to the right, and click enter. When it says guess, we can ignore that and just click enter again. Before I click enter, I want to show you something. Up at the top, I have these 2 arrows. My vertex should be in between those 2 arrows. As long as the arrows are pointing in towards my vertex, I've done it right. If they don't point in, then I've probably done it wrong. But once it says guess, you click enter again, so I just followed these steps. I went to the left using the left arrow, enter, right using the right arrow, enter, and then enter when it says guess. So my minimum is -1, -4. So my vertex was a minimum at -1, -4. The axis of symmetry does not come from the graph, it comes from your vertex. So x equals -1. For the x-intercepts, we're going to follow these steps. Remember, x-intercept, zeros, root, solutions all mean the same thing. So I go back to second trace, and I click 2, because 0 is the only word that looks like one of these. Be very careful, because 5 is an intersect, but we want intercepts, and those are not the same thing. So the only one on here that looks like x-intercepts, zeros, roots, or solutions is the word 0. So I click enter, because that's what I want to use. Now I'm going to use my cursor, and this is important. I'm going to scroll to my x-intercept, or my 0, or my root, or solution. So I'm looking for where it crosses the x-axis about here. Once I'm there, I now follow my instructions. When it says left bound, you can click the left arrow 3 times. 1, 2, 3, and click enter. Now it says right bound. So from where you're at, you can click right 6 times. 1, 2, 3, and that put us back where we were on the x-intercept. 4, 5, 6. Now some teachers just teach you to go back to the x-intercept and always use 3, or you can use 3 and then 6. But now my x-intercept's here, I'm on the right of it, so I click enter. Notice again, we have these arrows. These arrows should be on either side of my x-intercept. The x-intercept that I'm referencing, I will put my cursor on so you can see my arrows are on either side. So if they're not on either side, then you've made a mistake. Now you don't have to move the cursor after you click right bound. You can just click enter for guess, and it will tell you that your 0 is at -3, 0. So this one will even tell you the points of like where the 0 needs to go. We're going to do it one more time because I have 2 solutions. So I go second trace 2. This time I need to go over to my other x-intercept, so it's about here-ish. You don't have to be on it exactly, just be close. So I'm going to click the left arrow. It's asking for the left bound. So left arrow, 1, 2, 3, and click enter. Now it's asking me to go to the right, so because it's the second thing I've done, I'm going to double up, 1, 2, 3, 4, 5, 6, and click enter 2 times. And my other 0 is at 1, 0. So I can label on my graph, I have my vertex at -1, -4, an x-intercept at -3, and an x-intercept at -1. Now I'm going to find the y-intercept. The steps for the y-intercept is down here. So to find the value, and remember the word value means a y. So if you're trying to find a y, we're going to click second trace 1, enter the x value, and press enter. Now we have to think a little bit on this one. For a y-intercept, your x value is 0, and you have a number for y. So if we're trying to find the y-intercept, my x value here will be 0. Now you can use this tool for any of the missing pieces. So if I go second trace 1, if I think my x-intercept's at 1, I can click x is 1, what is y? If y is 0, I found my x-intercept. But we want to find the y-intercept. So the y-intercept is where your x is 0. So when x is 0, I did second trace 1, I've entered 0, and I press enter. And it tells me, it even shows me where it's crossing the y-axis at 0, -3. So you have to remember that your x is 0 for your y-intercept. And then we can draw that down here. So as long as you remember that an intercept is where the other one is 0, you'll be fine. All right. Now this one is asking us for f of 2. 2 on the inside is an x value, so we can use those steps again. Second trace value. When x is 2, I want to know what y is, and y is 5. Alternatively, we've done this before, you can go to the table and scroll when x is 2, y is 5. Okay? And then for my range, I know that my range deals directly with my vertex, which is a -4. My y's are starting low and going high, so my y's are getting greater than or equal to -4. So problem 2 is asking us for very similar stuff. They give me -2x² plus x plus 7, and they ask me to do all the same stuff. So I'm going to go back to y equals. I'm going to insert a -2 in front of my x². plus x plus 7. So I'm putting in all of the information that I have. And I'm going to go to my graph. In order to find the vertex, we have to first determine if it is a max or a min. Because this one looks like a hill, it is going to be a maximum. So to find my vertex, again, this is on your calculator tip sheet. You click second, trace. I have a maximum, so I go to 4 and click enter. This is about where my vertex is. I don't know for sure. It could be a little to the right. But they want me to go to the left of it, so I hit left a couple of times and click enter. Now they want me to go to the right, so I can go back up to the top, now go to the right, and click enter. Every time you see guess, you just need to click enter again. So my vertex is kind of ugly, 0.25, 7.125. So it's a good thing we didn't guess 0.7, which is what it first showed up as, because that is not my vertex. So the calculator will give you the exact point of your vertex. So I can draw my rough sketch. Obviously my drawings are very rough. And my vertex is at 0.25, 7.125. Okay, so again, steps for finding the vertex, you have to determine if it's a max or a min. After you've chosen that option on the calculator, go to the left of it, enter, go to the right of it, enter, and then enter again. My axis of symmetry is directly related to my vertex. There's nothing I need from the calculator on that, and it is x equals the x from my calculator. So problem 2 for the roots. Remember, roots, x-intercept solutions, zeros all mean the same. So the second trace menu is kind of my home base. This is everything I want it to calculate. I want to calculate the roots, which is the same as zeros. So I click 0 because that's the only one that looks very similar to what I have. I scroll to about where it crosses the x-axis, so about here. It's asking me for left bound, so I click left. 1, 2, 3, enter. To go to the right, this is the second direction, so I double up and hit 6. 1, 2, 3, 4, 5, 6. Click enter and enter again. So one of my roots is at negative 1.637. Some very ugly stuff. And then I'll do it again. Second trace 2. This time I want to go over to the other side, so I'm looking for this x-intercept. So ask me to go left, so 1, 2, 3, on the left arrow, enter. Double up because it's the second time, 1, 2, 3, 4, 5, 6, enter, enter. So my second 0 is 2.137, comma, 0. To find the y-intercept, we click second trace value, so second trace enter. I know that my y-intercept is where x equals 0, and I click enter to figure out what that is. So my y-intercept is 0, 7. So there's everything I've found so far on my graph. Okay, 2 more things they want us to find. Domain for all quadratics is always all reals. And then h of negative 5, they're giving me an x value inside the parentheses. So again, if I do second trace value, I want to know when x is negative 5 and click enter. It shows me right here when x is negative 5, y is negative 48. So we can't even see that on the graph. Again, you could also go second table, scroll up to where x is negative 5, y is negative 48. So there's 2 ways to solve that one. Problem 3 just asked me for the solutions axis of symmetry in a rough sketch, so we don't have to find all the stuffs. However, before I can plug in, I need to make sure I have an equals 0. So to make that a 0, I'm going to add it to move it, because negative 10 plus 10 cancels. And on the left side, I have x squared, 7x, and a positive 10. So I will put this into y equals. So x squared plus 7 x plus 10. And click graph. So the word solutions means x-intercepts, roots, and zeros. So when I go second trace, the only one that's like that is 0, so I click enter. I scroll to about where my x-intercept is, and I go, it says left bound, so I click left, 1, 2, 3, enter. Right bound is the second thing I'm doing, so I double up, 1, 2, 3, 4, 5, 6, and enter twice. So one of my solutions is at -2. Let's go find the other one. Second trace, 0, scooch to the other one. Left bound, so I click left 3 times, 1, 2, 3, and enter. Right bound, so I double up, 1, 2, 3, 4, 5, 6, and click enter 2 times. So my second 0 is at -5. So because this one's not very big, I can draw some tick marks and do a rough sketch with some ticks. That's a little more accurate. Okay. The only other thing they asked me to find is the axis of symmetry. So you have 2 options here. One, you can find it by hand, or you can find the vertex on the calculator and use that X. So just to show you the calculator steps again, this is a minimum, so I click second trace, min. I go to about where my vertex is, and then left bound, so I go to the left a little and click enter. Go back to my vertex, go to the right a little bit and click enter 2 times. So my vertex is at -3.5, -2.25. So my axis of symmetry is x equals the x from my vertex. So problem 4 says, what is the 0 of r of x equals -5/3 x plus 15? The first thing we want us to look at is look at your x here. What is the exponent? So we've been looking at what happens when x is 2. When x is 2, you have 2 solutions, but here x is a 1. So we should have 1 root. Now let's check and see if we're right. We're going to follow the same steps. So I have -5/3 x plus 15. I click graph, and I can see that this looks like a line. Remember, roots means where it crosses the x-axis. Well, it only crosses 1 time, so I can still follow the same steps. I need to go to my 0. So that's about where it crosses. It shows me left bound, so I go left, 1, 2, 3, and click enter. Go to the right 6 times, 1, 2, 3, 4, 5, 6, enter, enter, and my 0 is at 9. Now it also asks us for our axis of symmetry. Well, remember, the axis of symmetry is where you could fold your paper and the left side would match the right side. It is always an x equals line. Well, there's nowhere on this graph, nowhere over here, that I could fold up and down and the left side would match the right side. So the axis of symmetry only works for quadratics. It does not work for linear equations, not in the same way at least. Okay. So problem 5, they asked me to identify the solutions. That's all we're doing here. So I'm going to type back in -4.5 x squared plus 72. Notice that I already had an equal 0, which is why I went straight to the calculator. And I click graph. So my 2 solutions here and here. So second trace is our home base. I want to find the zeros. Something that will help you, if you don't know where your cursor is, kind of look around here. It tells me it's at x is 0, y at 72, which means it's way up here. So I need to click this for a while. Oh, I clicked it for too long. Okay, so this is about as close as I can get to my left bound, or to my intercept. So left bound, I go left, 1, 2, 3, and click enter. I click the right 6 times, 1, 2, 3, 4, 5, 6, and enter. And remember, these little arrows right here are still showing up. So even though we can't see where we're clicking, they're still showing up, meaning we're doing whatever's okay. I click enter again, and it tells me I have an x-intercept at -4. We're going to hop over to the right side, do it again, second trace 2. My x-intercept's about there, so I go left 1, 2, 3, and click enter. I go to the right 6, 1, 2, 3, 4, 5, 6, and click enter twice. My other 0 is at 4. So I got a -4 and a +4. It's something like that, way high. Problem 6 asks me to label true or false for the following statements. They're asking me about roots, minimums, real solutions, range. So I'm going to type this in to see what it looks like because I don't have a graph in front of me. So parentheses x minus 3 close parentheses squared. So I put it in exactly like I see it, and I click graph. Let's see what's going on. All right, so I can see right now this is a minimum, so B is going to be true. For the range, it looks like 0, but let me find my vertex. So this is a minimum, so I go 3. I go to my vertex first and go to the left a little, enter, go back to my vertex, to the right a little, enter, enter, and my vertex is at 3, 0. This really ugly number, anytime you see an E with a negative, that basically means 0. So it means that wherever I went left or right just wasn't quite exact for it, but it's 3 with a bunch of zeros, so it rounds to 3. And then E to the negative something means it's a 0. So that means as it crosses or touches, there's my vertex at 3. And then my Y's are going up, so they are getting greater than 0, so that's true. And then has no real solutions. Well, that's false because we just found that the vertex crosses, so it at least crosses 1 time. Now, one thing I can do is I clicked zoom, and I'm going to zoom in. So you see where my little cursor is? Looks like a little bug going across the screen. Wherever you put it, like I want to know what's going on here, so I've put it, I'll scoot it up for you. I'm putting it about where my vertex is and click enter, and it will zoom in for you so you can see what happens. I can see now that it is touching and bouncing. It's not doing 2 tiny little crosses, which means it does have 1 root at 3 because it's not crossing 2 times. So again, I did second zoom in and then put my cursor where I wanted it to go. Remember, second zoom 6 puts you back to normal. But from here, we couldn't see if it was bouncing or crossing twice, so that's why I zoomed in.